Today is the 6th of this October 2023, and I would like us to look at quadratic equations and quadratic graphs. Okay. Thank you to everyone who has been watching our videos. Okay. Please subscribe, share, like, and follow us. And please leave us some nice comments. We would really appreciate that. I normally write, please follow my notes /script. Okay, these are my notes. I prepare them before I record them, and I've gone through several times. Okay, if there is a mistake, I'll correct it. If there is none, maybe I'm going through and maybe something I will. But at times like this is 2 times pi times 45. Okay, so if you hear 2 times pi times 4 or 5, please go by the notes. Okay, thank you very much. Please beware of scammers. That's all I'll say about that. Okay, don't beware of them. Just be vigilant. Okay, be very vigilant. Okay, protect yourself online. Okay, now recap. We look at finding area, a circumference, and we said another word they might use is perimeter. Perimeter is normally associated with triangles, squares, quadrilateral, rectangles. Okay, circumference is basically linked with circles, but they might ask you to find the perimeter of a circle, which is the same as the circumference. Okay, and then we look at radius of a circle. Look at last video, the video we just did. Okay, a last video. You can get everything in there. Okay, let's look at the example for our recap. Okay, now there's a circle here, 45 millimeters. Okay, so that is the unit. The radius is 45 millimeters. So given a radius of, given a circle of radius 45 millimeters, okay, find the area and circumference / perimeter of a circle. Leave your answer to 1 decimal place. So here, straight away, whatever answer we get, okay, we need to leave it to 1 decimal place. Now the circumference of a circle is C equals 2 pi r. Okay, so 2 times pi times r, which is 45 millimeters. So if you multiply 2 times 45, which is our r, and multiply again by pi, which I know by now, you know how to use your calculator to do the pi calculations. You should get 282.7 millimeters. Okay, is circumference, so millimeters. leave your answer to one decimal place. So that is one decimal place. Okay, 282.7 millimeters. Now let's look at the area of the circle with radius 45 millimeters. Okay, area is pi r squared. So pi and then into brackets r is 45 and square. So if you square 45 on your calculator and then multiply by pi, so you just press the shift and press pi and multiply, okay, by whatever you get from 45 squares. You get 6362.6 millimeters squared. It's an area, so your unit will be millimeters squared. Do not forget your unit, and again to one decimal place. So this is what we've been doing in our last video. Okay, I will encourage you to go back and watch it if you've not watched it already. Now I'll start out. We have the line y equals x plus 3. Okay, we've done linear graphs already. Okay, now we want to have a look at it again because we are going to need it for the next few videos. Okay, y equals x plus 3. Find the values of y for x equals minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. So basically, x is in the intervals minus 3 to 4. So I have a table here. X minus 3 minus 2 minus 1, 0, 1, 2, 3, 4. I'm using the intervals they gave me. Okay, so if they've given you these intervals, stick to it. Don't do minus 10 to minus 10 because you are wasting time and you won't get any extra marks for that. Actually, they might mark you down if you do that because you are not following instructions. Okay, so now when x is minus 3, minus 3 plus 3 is 0. When x is minus 2, minus 2 plus 3 is 1. When x is minus 1, minus 1 plus 3 is 2. Okay, so our work on integers is becoming very handy. When x is 0, 0 plus 3 is 3. When x is 1, 1 plus 3 is 4. When x is 2, 2 plus 3 is 5. When x is 3, 3 plus 3 is 6. Okay. When x is 4, 4 plus 3 is 7. So we've done it in a table form. Okay, and then this is a linear graph because x is to the power 1. Okay, we've looked at this. Okay, so assuming they ask us to go ahead and plot this on a graph or on the x and y axis, then we are going to find and we are going to use a scale and then do our graph for the x-axis and the y-axis. Note y here is the minimum amount is 0 and the max is 7. So on the y-axis we need 0 to 7, and the x-axis we have -3 to 4. So we are going to have that in mind. So the x-axis we might give some negative bits, and the y-axis we might do the -1. Okay, guess to find out the character of the line graph. Okay, and then we will plot using the points that we've had. But if they've not asked us to do that, that would be what we'll leave them with. Okay, now let's go on. Today we want to look at quadratic equations and then plot one quadratic graph. Okay, and then we'll continue in the next video. Okay, we've looked at linear equations and linear graph. We've just looked at an example in the starter. Okay, and we've used those to plot, okay, line graphs. Linear means a line. So if we see a linear equation, it will give us a line graph. Okay. Now, an example of a linear equation is y equals 2x plus 4, where x is always the power 1. Okay, it doesn't go further than 1. Okay, if x is 0, then y equals 4, and you can draw y equals 4 on your graph. Okay, sorry. We know how to plot coordinates on the x and y axis. We've done that. Okay, I think I expect you to know that because we've done that. If you haven't done that, again, go back and watch the video and help yourself. Today we are examining quadratic equation and quadratic graph. So by now, if you see a linear equation, you should be like, oh, x is the power 1 in this equation. Okay, so that is a linear graph. So for instance, a linear equation, x is always the power 1. Okay, you might get y equals x, or y equals 2x, or y equals 2x plus 4, or y equals x minus 10. All those are linear graphs. Okay, now with a quadratic graph, the x becomes x squared. That is the difference. Okay, a is never equals 0, because if a equals 0, all this part becomes 0, and then you have a linear graph again. So for a quadratic graph, this word quadratic, a is never equals to 0. Okay, a can be minus, a can be 1. Okay, so you can have minus x squared or a plus x squared. The highest power of x should be 2 for a quadratic graph. Okay, so example of quadratic equation. So before we plot the graph, I need to show you what the quadratic equation looks like. So y equals 2x squared plus 6. This x squared here tells us it's a quadratic graph. So if we have some x value and we substitute and we plot the graph, we are going to get a curve. We won't get a straight line. Okay, a linear graph will give us a straight line. A quadratic graph will give us a curve. Okay, Now, y equals x squared plus 9x plus 1. Because of this x squared, okay, it's a quadratic equation. Y equals 6x squared minus 1. Again, because of this x squared, it's a quadratic graph. Y equals 7x squared plus 10. Again, because of this x squared, it's a quadratic graph. Y equals x squared minus 3. Again, this x squared here tells us it's a quadratic graph. Y equals 2x squared plus x minus 7. Again, the x squared. Okay. Y equals 5x squared plus 3. Again, the x squared. Okay. Y equals 3x squared minus 3. Again, the x squared. So if I have an equation, I'll be looking at the character of the x's. Okay. If there's no x squared and I'm supposed to plot a graph, then it's possibly a linear graph. If there's an s squared and I'm supposed to use it to plot a graph, then it is a quadratic graph. Okay, and it means I'll end up with a curve. So let's look at this graph here. So example, plot the graph of the quadratic equation. Y equals x squared minus 2 in the intervals of x from minus 4 to 4. So on the x-axis, they've limited us from the value of minus 4 to 4. Okay, so I'm going to use the table method here. Okay, and so that to be systematic for me. So here, x is minus 4 to 4 as I've been given in the question. Okay, so I'm going to plot a table. Minus 4, minus 2, 3. Minus 2, minus 1, 0, 1, 2, 3, 4. All these are integers, okay? Negative and positive whole numbers, including 0. Now, the equation is y equals x squared. So now that I have x, my first step is to put in x squared from the equation. So minus 4 squared is 16. Remember, we said the square root of 16 is plus or minus 4. Okay, so minus 4 squared, because it will have two negative numbers, two negatives, it becomes positive. Minus 3 squared is 9. Minus 2 all squared is 4. Minus 1 all squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. Now, the second part is minus 2. Okay, so now we put minus 2 and repeat minus 2 for the next column. Okay, so minus 2, 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 minus 2. So now we have x squared here in this row minus 2. Okay, so now x squared minus 2 will give us y. So 16 minus 2 is 14. 9 minus 2 is 7. 4 minus 2 is 2. 1 minus 2 is minus 1. 0 minus 2 is minus 2. 1 minus 2 is minus 1. 4 minus 2 is 2. 9 minus 2 is 7. 16 minus 2 is 14. Okay, so now we have the x value on top here, and then we have the y value on top down here. Just by so with the table is more systematic. Okay, so when is x is minus 4, y is 14. Okay, so here is my graph. Okay, so I've written the coordinates here, okay, for x and y from the table I just did. Okay, so when x is minus 4, y is 14, so x here minus 4 and y is 14. Now let's look at the graph. So I have, if I look at my coordinates properly, I've been told x should be between minus 4 and 4, which I have done for the x-axis here. So I started from minus 5 to 5. Okay, I've just added 1 unit just to listen, but I'll stop at 4. Okay, I don't need to go to 10. Now, when I found y, I realized that the minimum value for my y is minus 1, and the highest is 14. So because of that, my y-axis, I started from minus 4, okay, because I gave equal intervals of 2 units, again by eye judgment, not to scale. Okay, so minus 4 minus 2 is 0, and then 2, 4, 6, 8, 10, 12, 14. Okay, now I have just written the coordinates here because I'm using a different paper. I didn't want to be going from there to there so that I mix the numbers. Okay, so I've written all my coordinates down here. So when x is minus 4, I have 14, and then I have a title for my graph of y equals x squared minus 2. Okay, I've labeled my y-axis and I've labeled my x-axis. Okay, all in pencil. Because I'm not writing on a graph paper, I have written my title in pen. But assuming I had to do this and write on the graph, then I'll write in pencil. Okay, and that's my origin. I didn't have to shorten this graph, okay, because the values I got for x and y, the coordinates I got, I can easily use the origin. So now when x is minus 14, minus 4, y is 14. So here I use a ruler. Okay, let me show you. Okay, I use the ruler minus 4 all the way up to 14. So that is my point here. Okay, we've plotted points and it's in one of our videos. So if you can have a look at it, okay, it will help you a lot if you don't know how to plot a graph. Okay, because I assume it's not everyone who is watching this video at the moment who started with us from the first video. When x is minus 3, y is 7. So when x is minus 3 here, okay, y is 7. So a little above 6, again not to scale. Okay, so that's our 7 here. When x is minus 2, y is 2. So when x is minus 2, y is 2 there. So x minus 2, y is 2. When x is minus 1, y is minus 1. So when x is minus 1, y is minus 1 here. Okay, there. When x is 0, y is minus 2. So when x is 0, y is minus 2 there. When x is 1, y is minus 1 there. So when x is 1, y is minus 1, this point here. When x is 2, y is 2. So when x is 2, y is 2 there. When x is 3, y is 7. So when x is 3, y is 7, between 6 and 7, 8 here. So 7 will be somewhere here, there. Again, not to scale by eye judgment. When x is 4, y is 14. So when x is 4, y is 14. So there. Okay. So now, after that, we try and plot. We know it's a quadratic, so we're expecting a curve. So we try and plot it, okay, all the way to join the point. So this is the curve, okay, of the quadratic equation y equals x squared minus 2. Now that bit here is the turning point, okay. The turning point is where the graph turns round and go back up. So you might even have this graph, a quadratic graph that goes up and then turns back down with another turning point, okay, like waves, okay. So now this is our turning point here. So assuming they ask us to find the turning point on the graph, then this will be the point we'll give, okay, which is 0 minus 2, okay. Now on this line, the x-axis, y equals 0. So this is the line y equals 0. So assuming in the question they say to us, find the coordinates when x is 0, okay, no, find the coordinates on the x-axis or when x is 0, then these are the 2 points we are going to give them, okay. Quadratic, so you need to give 2 points. If we did our calculation wrong on the table, we might not get a curve, Okay, we might not get a point going up this word. Okay, so then we quickly have to go back and check and see if there is any mistakes. But as I always said, it's better to take your time to do the question and get as much marks as you can than to get find out that there's something wrong and then you have to go back and redo it again and then put yourself under stress and then you are not able to do the other questions or do it properly. Okay, so here we are, okay, with our quadratic curve. Okay, tomorrow I think what I'll do is I've just showed you the line x on the x-axis where it casts the 2 points. Okay, so tomorrow we might have another curve and then we might have another linear line and then we'll see where it cuts. Okay, and we'll discuss that. And then maybe if we have time, we might draw 2 quadratic graphs and see where they intersect. Okay, and then we'll have time to explain all of that. Okay, so at the moment, this is what we have today. So assuming they said to us, draw this quadratic curve, okay, and also draw the line y equals 4. So this point y equals 4. So we are going to draw a straight line across and then they'll ask us to find the coordinates where it intersects. So it will be that point there and that point there. So we may have to find the coordinates after we've drawn that. So this is what I wanted to show you today. Okay, so quickly I've done a recap with you with area, circumference and radius of a circle. We've done an example. We've gone on to look at the starter to see how we can tabulate a linear graph with the points. Okay, but we didn't plot any linear graphs because we have a video on those. I've explained to you the difference between a linear equation and a quadratic equation. Okay, and I've told you that we've done the linear equation for which is a straight line and a quadratic equation, and I've shown you some examples. Okay, and also we've drawn a quadratic graph. Okay, so this is what I have for you today, and I've shown you the turning point. Okay, and I showed you how I decided on my interval for the y. Okay, so thank you very much for watching the video today, and I'll see you in the next.